Okay, hello Algebra 2 people. Here is your video for practice exam number 1. So we start off with, for what values of x is the expression undefined, which is another way of asking what makes the denominator equal 0. So remember, when you are factoring something that has a number in front of the x squared term, you have to put a times c on top, so 2 times -2, -3 here. So we're trying to see, we're going to have to factor this. And so we are going to know that a -4 plus 1 would give me a -4 as a product and a -3 as a sum. So then what we did was we took and we rewrote the middle term using what we have here in the middle, so 2x squared minus 4x plus x minus 2, and we could factor out the 2x, which left us with x minus 2, and then all we're doing is factoring out a 1, so this factors into 2x plus 1 and x minus 2. When you set each term equal to 0, you get a -1/2 and you get a 2. So a -1/2 and a 2 would go with C. Either one of those would make the denominator 0, so that's an excluded term. Number 2, what common denominator is needed? So once again, we're going to have to factor. So this one, we don't really need to do the diamond. We know that 3 times 2 is 6. And if we have a positive 3 and we subtract 2, forgot the m there, that would give us a positive 1. So I have 3 denominators. I have m plus 3, I have m minus 2, and then I have the other denominator of n plus 1. That's what our common denominator would be. And so let's see, where would that be? We have a plus 1, a minus 2, and a positive 3, so that would give us A. Now we want the vertical and horizontal. So remember, the vertical asymptote is what makes the denominator equal to 0, and in this case the horizontal asymptote, that's when you have the A over x minus h plus k. The horizontal asymptote is y equals k. So our vertical asymptote is going to come from here, x equals a positive 1, and our horizontal asymptote is going to be y equals a -3. And that one goes here. I realize the numbering AB is a little off, but there's your answer. Okay. Given the following data, explain how you know the relationship is an inverse variation. So we know it's an inverse. Why? Why do we know that? Well, if you look at, here's your general form, y equals a over x. If I cross multiply, that's x times y equals a constant number. So if I multiply x times y, notice I get -36, -36, -36, and -36. Which will end up being our A value. So how do we know? Because x times y equals a constant value. So then what is that relationship? Y equals -36 over x. That's putting it as a function. And then find x when y is 2. So we have 2 equals -36 over x, put this 2 over 1, cross multiply, that gives you 2x equals -36, so x is going to equal a -18. Okay, so now we're going to start with our simplifying. So a lot of these are just, initially we're not solving, we're just simplifying. So we want to factor everything out that we can. So here on top, I can pull out a 5y, and that leaves me with a 2y plus 3, and you can always just double check if you distribute back through that you got the same thing. And on the bottom I can pull out a 5y as well, and I'm left with 7y minus 1, and so the only thing to cancel out are the 5y's, and that leaves me with my answer of 2y plus 3 over 7y minus 1. Now this next one, there's a lot of components here, so we're going to do this slowly. I can simplify each fraction by itself first, if that's easier, and then I'll rewrite it as a multiplication. That doesn't matter. You could do that if you want. So if I did that, 2 of these x's will cancel with 2 of those, so that I have x squared down here. This y will cancel with 1 of those y's, so I have y squared. I still have z to the 5th, I still have the 4, and I still have a 3. On this other side, this z will cancel with that one of those z's, so I still have 2 of them. One of these y's cancels with one of those, so I have 3. And then one of these x's cancels with one of those, so I still have x squared. And I have the 16 over the 9. Now I have to rewrite it so I have my invert and multiply. So the first fraction doesn't change. 4y squared z to the 5th over 3x squared times, now I have to flip. So the 9 goes upstairs, and I have 16x squared y cubed z squared. Now that I have multiplication all the way across, anything on top cancels with anything on bottom. So this 3 goes into the 9 3 times. This 4 goes into the 16 4 times. These 2 y's cancels with 2 of those, so I still have a y. And let me see, these 2 z's will cancel with 2 of those, so I still have z cubed. And we can then put it all together. So on top, all I see is a z cubed and a 3. So I have 3z cubed on top. And on the bottom, I have x squared here. I have an x squared here. So, and I have a 4, so I have x to the 4th, x squared times x squared, and I have a y. And that's it. Okay, the next one again, factor, 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 but notice this first one, it would be a lot easier if we pull out a 2 first, so x squared plus 7x plus 10, so that becomes 2x plus 5x plus 2. On top here, I have a difference of squares, so 2 minus x, 2 plus x. Over here, I've got x minus 2. I'm just going to rewrite it on the same row. And this one up here, again, you could do your 15 on top, 16, so this will be 15 and 1. And I'll let you do the grouping, but I know that I'm going to have a 3x, and since 3x goes into 15, the 5 will have to be over here. 3x times 5 is 15, so this other factor 1 will go here, and everyone is positive, x plus 5. So you can double check, but if you do your grouping, that's what you will end up with. So now we're ready to cancel. Everything is factored. Oh, sorry. That was my dog. Okay, so this x plus 5 cancels with that x plus 5. This x plus 2 cancels with this 2 plus x, x plus 2, it's the same thing. What's tricky in this problem is the x minus 2 here. It will cancel with this 2 minus x, but they cancel into a negative 1. Okay, because they are opposite of each other. It's as if you factored out a negative 1. So now what I'm left with is let me see, on top I have negative 1 times 3x plus 1, and on the bottom all I have is 2. Okay, so again, the tricky one here was the 2 minus x over the x minus 2. If you look at it as if I pull a negative 1 out of this top term, I would have negative, why is this not writing very well? I have negative 1, that would make the 2 negative and the x positive, and I still have x minus 2 on the bottom. So notice they cancel each other out, leaving you with just the negative 1. Okay, number 8 are those complex fractions. So what we're going to do is emphasize that this here was our division, okay? So we're going to write this, we have 5x minus 1 over, and I'm going to just start to factor, so we have x plus 5, x minus 5, so that's this fraction here, times, and I'm going to go ahead and invert and multiply, so this one gets inverted and multiplied, so I have x plus 5 here, and on the bottom I can pull out a 2, and that gives me 5x minus 1. So now we can start to cancel things out. So this 5x minus 1 goes with that 5x minus 1, this x plus 5 with this x plus 5, and all you're left with is a 1 over, don't forget there's this 2 sitting here, 2, sorry this is, I don't know, my pencil's not writing very well, and then 2 times x minus 5. So I filled that in. Okay, so we had this and the 2. We had the x minus 5 and the 2 left. All right, 3 more problems on this page. So this one is just common denominator. So 6 and 8 both go into, the smallest number they go into is 24. So that means this one needs 4 over 4, and this one needs 3 over 3. And this one has an A and a B. This one only has the A, so it also needs a B. So notice we now have 24AB in each denominator, which is our goal, so they all have a common denominator. So on top we've got 4 times 5 minus 7 times 3 times B, and you're done. That's really all you can do. So we have 20 minus 21b, because again that's just a unit there, and we have 24ab. So the b's do not cancel because it's on top, it's next to addition and subtraction. Okay, on number 10, our common denominator is going to be the product of these two things. So the second term needs a 2, so we're going to put things in parentheses. And this first term is going to need x minus 3. So this will be x minus 3 over x minus 3. Okay, so that means we're going to have to FOIL. So we know, well, we'll put down our denominator, 2 times x minus 3. And on top, I'm going to have to FOIL this. So I have 3x times x, so 3x squared. And then 3x minus 3, so minus 9x. And then 2 times x, so plus 2 times x, and then 2 times a negative 3, and then minus, so this 2 has to distribute, but there's also the negative, so it's going to be a minus 2x, and a minus 2 times 4, so that's minus 8, so be careful with this negative here. And then we just have to combine like terms. So 3x squared won't combine with anything. 9x, let's see, the plus 2x and the minus 2x cancel each other out, so we have a minus 9x, and then minus 6 and minus 8 is minus 14, and that's all over 2 times x minus 3. Okay, one more. So again, factor, 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 so this is 2 times x minus 9. This one is going to be, let me see, 36, 9 and 4. So x minus 9, x minus 4. So they both have a common factor of the x minus 9, so that's good. They're both going to need a common factor of 2, so this one will have to get multiplied top and bottom by 2. And the second one needs the x minus 4. And so then I have a common denominator of 2 times x minus 9, x minus 4. And when we simplify across the top, we have 6 plus 4x minus 16. So that's going to equal 4x, and let me see if I can get rid of this little piece. So we have 4x, 6 minus 16, so minus 10, over 2 times x minus 9, x minus 4. However, there is still a common factor of 2 in this top, so we have, I could pull out a 2 and I'd have, sorry about that, if I pull out the 2, I have 2x minus 5, so this 2 will cancel with that 2, so 2x minus 5 over x minus 9, x minus 4. Okay, graphing. So notice these are both of different formats. So this first one is this format, x minus h plus k. So h is going to be our vertical asymptote, so x will equal 4 because it makes the denominator 0, and y equals 1. Make sure you include the x and the y. Some of you learned that on the quiz. So x equals 4 would be here, and y equals 1 is going to be here. And now we want to know where to draw the graph. So you could also, some of you might recognize the negative 2 tells us something about it'll probably be in the second and the fourth quadrant, but it's not a bad idea just to plug in a point. And so if I were to plug in 0, it's always a nice easy one if you can, that would give me a negative 2 over a negative 4, which is 1/2 plus the 1, so that's 3/2. That would put me right here. And that tells me then that I'm going to be in this quadrant, which means the other one will be in the diagonal quadrant. But you can plug another point if you're not sure. All right, so that's there. The negative 2 also told me, though, that that would be in those two quadrants. Now over here we have a different ball game. For the vertical, it's still setting the denominator equal to 0, so x is a negative 2. The horizontal now, though, comes from plugging in large values of x. This approaches y equals 3. It would reduce. So we have a horizontal at 3 and a vertical at negative 2. And then when we draw the graph, we want to know what quadrant. Now with these, you definitely need to plot a value because it's not going to be clear. So again, I'm going to plug in 0. That gives me negative 2 over 2. So at 0, I'm at negative 1. And it turns out this one is also in these two quadrants. And that's good enough, just to get a sketch of where those will be. Okay? All right, on to solving. So we have different strategies we can use. On number 14, I'm going to do a common denominator everywhere because they're so closely related. So on the first one, and I'm going to make my common denominator be 8x squared. So the first one I need a 2 over a 2. The second one I need a 2 and an x. And the third one just needs an x. So now that I have all these bottom denominators the same, it's like I can get rid of them because it's like multiplying through by 8x squared everywhere would cancel them out. And all I'm solving for is 14 plus 10x equals 3x. So that means I have 14 equals a negative 7x. So x is going to be a negative 2. And notice it does not make any of my denominators 0. So that is a totally okay answer. On number 15, I'm going to create a proportion. And so what I'm going to first do is just multiply this by 2x over 2x to give that term a common denominator, so that I have x minus 3 plus 6, which is the same thing as x plus 3. That equals 5 over 1. So when I cross multiply, I have x plus 3 equals 10x. So 3 equals 9x. So x is going to equal 1/3. Now on 16, I think, let's see what happens when we factor this. We get x minus 2, x minus 1. So this is another case. Notice that everyone is very closely related. So it might be easiest just to go ahead and give them all the same denominator. So this one needs x minus 2. This one is going to need x minus 1. Now that everyone has exactly the same denominator, I can just cancel it out and solve across the top. So I have 6x minus 12 equals 4x minus 4 minus 10, and gather up like terms. So I have 6x minus 12 equals 4x minus 14. So 2x is going to equal, if I add 12 to this side, I still have a negative 2. So x equals a negative 1, which is lucky, because if it was 1, I'd have to throw it out. So x equals a negative 1, and that's an okay answer. Okay, last one. Deb and Kel are planting a garden. Deb can plant a ½ acre in 3 hours. Kyle can plant the same area in 4 hours. So for Deb, we have a rate of 1/3 of the area is the amount of work that she can do. And for Kyle, it's going to be, he can do 1/4 in an hour. And then we want to find out the time that they can do to finish one whole job. So t over 3 plus t over 4 equals 1 whole job. So common denominator would be 12. Whoops, sorry about that. That's going to be 3 over 3. So now we have our common denominator of 12. 4t plus 3t is 7t. And so you multiply by the reciprocal, 12 over 7. 12 over 7, that isolates your t. So 12 over 7 is about 1 5/7 of an hour, which is a lot less time working together than doing it individually. Okay, I hope that helped.